Hello everyone, welcome to Maths YouTube channel Maths Insights. I am your maths teacher Shiva. Today we are going to discuss very important properties of symmetric and skew symmetric. The first property says that if A is a square matrix, then A into A dash and A dash into A are also symmetric matrices. See, to understand this property in a better way, you have to know what is meant by symmetric and skew symmetric matrices. I made a separate video for this and you may watch that video. I am giving it as a icon. So if you click that, you will get that video, and after watching that video in full, then you can understand it is better. But I will say in brief that if A is said to be a symmetric matrix, then the condition is A dash is equals to A, where A dash is the transpose of the matrix. If a matrix is equals to its transpose, then that is said to be a symmetric matrix. The property 1 says that if A is a square matrix, then A into A dash and A dash into A are also symmetric matrices. See, if you want to prove any matrix is symmetric or not, you have to do the transpose of that matrix. See, I want to check this is whether it is symmetric or not. If I want to check it, I have to do transpose for that. A into B whole dash is equals to B dash into A dash. In this case, you have to treat it as A and this is B. Therefore, as per this property of transpose, you will get A dash whole dash. That means whatever the matrix in the second place, that comes in the first place with the transpose. See, this is the matrix in the second place coming in first place with the transpose into A dash. Again, you know that A dash whole dash is equals to A. This is also the property of transpose of matrices. A dash whole dash is equals to A, and I am writing A dash as it is. Whatever the matrix you have taken, you are getting back the same matrix again on doing the transpose. Therefore, this A into A dash is the symmetric matrix. Similarly, you can verify A dash into A whether it is also symmetric or not. Definitely you have to keep in mind that to verify any matrix whether symmetric or not, you have to do transpose for it. After doing the transpose, if you get the same matrix again, then that is a symmetric, otherwise not. So I am doing transpose for this to verify its symmetricity. Therefore, A dash again as per this AB whole dash is equals to B dash into A dash. A dash, that means whatever the matrix in the second place comes in the first place with a transpose. Again A dash whole dash, that is equals to A dash whole dash again is A. Therefore whatever the matrix you have taken, you are getting the same matrix again and doing the transpose. Transpose is nothing but interchanging of rows and columns. On doing that, you are getting the same. Therefore, the property 1, if A is symmetric matrix, then A into A dash and A dash into A are also symmetric matrices. The second property says that if A is a symmetric matrix, then minus A and K into A, where K is a scalar, A inverse and A transpose, all this will also become symmetric matrices. They have given the condition that A is symmetric matrix, means they are giving that A is equals to A dash. This is the condition. Wherever you want, you may use to prove these are also symmetric matrices. First, I will take to verify whether minus A is symmetric or not. Minus, I want to check whether it is symmetric or not, means you have to do transpose for it. Minus A whole transpose is equals to minus, actually you can write it as minus 1 into A whole transpose. Transpose will not applicable to the scalar, that's why you will write the scalar as it is, minus 1 into A dash. Minus 1 into A dash means again you will get A dash. But since A is symmetric, A dash will become A. See, minus will also come here. That is equals to, in the place of A dash, you may write A. Since A is symmetric, therefore minus A. So, whatever the matrix you have taken and doing transpose, you are getting the same matrix again. Therefore, minus A is a symmetric matrix. Next one is K into A. This is the first one. Second one is K into A. If you want to check it whether it is symmetric or not, as I said, do the transpose and you have to get again the same. Ka into whole dash is equals to. Transpose is generally applicable to matrices, not to constants. Therefore, this constant comes as it is, K into A dash, but A dash is equals to A. Since A is a symmetric matrix, that is equals to K into A. So, whatever the matrix you have taken, you are getting the same again. Therefore, K into A is a symmetric matrix. Third is, what it is? A inverse. For A inverse also, I will do transpose. You can interchange this transpose and that invertibility. That means A dash whole power inverse. That means A dash inverse. Inverse for A dash. But you can write for A dash as A. Since A is a symmetric matrix, therefore A inverse. So, whatever you have taken, you are getting back the same matrix again. Therefore, A inverse is also symmetric. The last one is, fourth one, A dash. See, you know very well about it. To verify its symmetricity, you have to do transpose for it. My dear students, you know A dash whole dash is equals to A. But A is equals to A dash, since they have given A is a symmetric matrix. Therefore, that is equals to A dash. Whatever the matrix you are taking, you are getting back the same matrix again. This is the second property, very important. A is symmetric if, then all these four matrices will become symmetric matrices. Minus A, K into A inverse and A dash. Property number 3 says that all positive integral powers of a symmetric matrix are symmetric. Why? Because A power n whole dash is equals to A dash whole power n. What they are saying? All integral powers of a symmetric matrix. Symmetric matrix means they are giving the condition that if A, you have taken A, then A dash is equals to A. This is the condition. Now, I want to prove that. What I am saying? All positive integral powers of a symmetric matrix. A is symmetric matrix, they have given. Now, I want to prove whether A power 15 is symmetric or not. If you want to check its symmetricity, I have to do the transpose. If I do the transpose for it, A power 15 whole dash, you can write it as A dash whole power 15. But A dash is equals to A, since A is symmetric. Therefore, you will write A in place of A dash power 15. Whatever the matrix you have taken, whatever the matrix, you are getting the same matrix again. Therefore, it says that if any matrix is symmetric, all matrices of positive integral powers will also become symmetric. Fourth property says that all positive odd integral powers, this is very important, odd integral powers of a skew symmetric matrix or skew symmetric. See, this is very important. Again, you have to know what is meant by a skew symmetric matrix. If A is equals to minus A dash, previously the condition for symmetricity is A is equals to A dash, but if A is equals to minus A dash, then this A is said to be skew symmetric matrix. This property says that all odd integral powers of a skew symmetric matrix. Suppose they have given this condition, you may use this condition wherever it is required. You have to verify by taking a matrix with odd integral power. I am taking A power 5. I have to verify whether it is symmetric or skew symmetric. To verify it, for every matrix you have to do the transpose. If you are doing the transpose, you have to get, what you have to get? Minus A. this minus may be taken this side. That means A transpose is equals to minus A, then that is said to be skew symmetric matrix. I am doing the transpose, that is equals to, you may write A dash whole power 5, you can interchange these two, but A dash is equals to minus A whole power 5. If you multiply this odd number of times, you will get minus again, therefore minus A power 5. Whatever the matrix you have taken, you got the negative of that on doing the transpose. Therefore, this is said to be skew symmetric matrix. Again, if the power of this matrix is even, if it is a skew symmetric and its power is even instead of odd, then that will become symmetric. Say I am taking A power 4. A power 4 which is even power of the matrix, I am doing the transpose for it, therefore A dash whole power 4. But since A dash is equals to minus A, I can write it instead of A dash minus A whole power 4. If you multiply minus A even number of times, whatever the even number may be, you will get A4 again. That means this minus will disappear. Whatever the matrix you have taken, you are getting the same matrix again and doing the transpose. Therefore, it will become a symmetric matrix. The fifth property is, if A and B are symmetric matrices, then A plus or minus B and AB plus BA are also symmetric matrices. They have given the condition that A and B are symmetric matrices, means A is equals to A dash and B is equals to B dash. You may use this whenever you want in this case. The first one is, you have to prove that A plus or minus B is a symmetric matrix, means you have to take the transpose for it. And if you get back the same matrix, then that is symmetric, otherwise not. This will become A dash plus or minus B dash. But A dash is equals to A and B dash is equals to B. Whatever the matrix you have taken, you are getting the same matrix again. Therefore, the matrix A plus or minus B is said to be symmetric matrix, and the other matrix AB plus BA is also. See, I am taking this one, AB plus BA. You know, the transpose of any matrix is equals to itself, that is said to be symmetric matrix. Now I am doing the transpose to verify whether it is equals to itself or not. Okay, so this is AB dash plus BA dash, that is equals to AB whole dash is equals to, you know very well, that is B dash into A dash. Similarly, BA whole dash is equals to A dash into B dash. But B dash is equals to B since B is symmetric. Therefore, you can write it as BA plus AB, which is equals to AB plus BA again. Therefore, you are getting the same matrix on doing the transpose. Therefore, this matrix AB plus BA is said to be symmetric matrix. Third one, second sub property in this is AB minus BA. AB plus BA is symmetric, but AB minus BA will become skew symmetric. What is the condition for skew symmetric matrix? If A is equals to minus A dash or minus A is equals to A dash, then that A is said to be skew symmetric matrix. So I am doing transpose for this matrix also, AB minus BA whole dash, that is equals to AB dash minus BA dash. Dash means transpose. AB whole dash is equals to, you know, B dash into A dash minus this is A dash into B dash. You know B dash is equals to B and A dash is equals to A. Since A and B are symmetric matrices, this is also A into B. But you are not getting the matrix AB minus BA, but you are getting BA minus AB. If you take minus as your common factor, minus 1, then you will get the original matrix, minus of AB plus minus of AB minus BA. See, you are getting minus of the original matrix. Therefore, it is said to be a skew symmetric matrix. The property, if A and B are skew symmetric matrices, then the first sub property is A plus or minus B and AB minus BA are also skew symmetric matrices, and the second property AB plus BA is symmetric matrix. What they have given, A and B are skew symmetric matrices, means A is equals to minus A dash and B is equals to minus B dash. Otherwise you may write it as minus A is equals to A dash also, and this is minus B is equals to B dash also. So by using this you can prove this A plus or minus B and AB minus BA are skew symmetric matrices. First I will take A plus or minus B whole dash. Whatever, if you want to prove symmetric or skew symmetric, you have to do the transpose. If you get the same matrix, it is symmetric. If you get negative of the matrix, then that is skew symmetric. So I am doing the transpose, that is equals to A dash plus or minus B dash. But A dash is equals to, they have given you, A dash is equals to minus A plus or minus B dash is minus B. Can I write like this? That is equals to, you may take minus common, then this is A plus or minus B. So whatever the matrix I have taken and doing the transpose, I am getting negative of that matrix, therefore this is a skew symmetric matrix. Similarly, AB minus BA, this is whole dash. You have to do whole dash whether it is to verify whether it is symmetric or skew symmetric. Therefore this is AB whole dash minus BA whole dash. You know AB whole dash is equals to B dash into A dash minus this is A dash into B dash. See, you can write B for B dash and A for A dash. Therefore this is B, but this is for B dash you can write minus B. Therefore this for minus A, for A dash you can write minus A. And also here for A dash you can write minus A and for B dash you can write minus B. My dear students, this is minus into minus will become plus, therefore this is minus BA plus BA and minus into minus again plus, this is AB. If you take minus common, in this case minus of AB minus BA, see you are getting negative of that matrix, therefore AB minus BA is also skew symmetric. The second sub property of the sixth one says that AB plus BA is skew symmetric. To verify its symmetricity, you have to do the transpose. I am doing here AB plus BA whole transpose, that is equals to. Similarly, whatever you have done here, you are doing the same thing here also. AB whole dash plus BA whole dash, that is equals to AB whole dash means B dash into A dash plus here A dash into B dash. But for B dash you can write minus B minus A plus minus A into minus B, that implies 2. So minus into minus will become plus, therefore it is BA plus again minus into minus plus, therefore AB. This can be written as AB plus BA. Whatever the matrix you have taken, you are getting the same matrix back. So it is a symmetric matrix. These are very important properties of symmetric and skew symmetric matrices. I hope this video is helpful to you. If you think like that, please don't forget to subscribe to my channel and share it and like it. We will meet again in the next video. Until then, have a nice day. Thank you very much.